In this video, we are going to be discussing electric circuits, but more specifically, we are going to discuss the question, finding the effective resistance. This is something introduced in grade 10 physical sciences and repeated through to grade 12. Alright, so the question generally comes across as determine the effective resistance of the circuit below, or it could ask you for your total resistance. Either or, they generally give you a circuit and they generally give you a combined circuit. Now, I just want you to take a look here. When looking at how this current flows, we see that we have the current going through one resistor after coming out of the battery, and then it splits over here. Okay, that means we have a resistor in series, and then we have two resistors in parallel. Alright, and this is repeated through all the way to metric. But that's not the point of this question. The question they asked you, the question is that they asked you for the total resistance. Now, when you find the total resistance, R total is actually a squish effect. It means what happens if I squish all of my resistors together. And after you squish them, you'll see the effect essentially is one resistor. So if you are given X amount of resistors here on the left hand side and you go and calculate the total resistance, your answer is pretty much one resistor within the circuit. And then again, if we had to consider the current flowing through that, we get everything going through that one resistance. That's actually what they're asking you to do when they ask you to find the total resistance or the effective resistance. Alright, so let's take a look. We can break this down into three different types. Type 1, a series circuit. Now, what does a series circuit look like? If you're not sure, how we know whether a circuit is series or not is we follow the current. Okay? Current. Now, to follow the current, you simply just go and look at where it goes out of the battery and what it goes through. There we go. Okay, so we have current coming out of the battery here, going through the circuit, and you'll see it goes through each resistor. Now, my question to you is this current splitting up before going through either of these resistors? And your answer should immediately be, no, it is not. Alright, it goes directly through each, which means that we have three resistors in series, R1, R2, and R3. Alright, and if we had to now squish them, the squishing now is a series circuit. So we find the R series, and what we do is we just add them together, R1 plus R2 plus R3, because current doesn't divide. And then we would get the resistance RS. Alright, and the result of that, remember, finding the total is your squishing effect, in other words, forming one resistor. And whatever you got as your answer here equals something ohm would be the value of this resistor over here. Alright, let's take a look at what that actually looks like with numbers. Let's say we get our series resistor again. Sorry, not series resistor. Yeah, our resistors connected in series again. So our series circuit. And let's say all of them have the same ohm. So let's say 3 ohms, 3 ohms, and 3 ohms. Now, finding the effective resistance there, we would go and say, okay, they are connected in series, so R series equals R1 plus R2 plus R3. Important to write the formula out. And that would equal 3 plus 3 plus 3, which equals 9 ohms. Never forget your unit. So the effective resistance of this entire circuit, if we had to look at all the resistors and consider it as one, would be 9 ohms. So squishing over, we get 9 ohms. Alright, let's take a look at a second type. Type 2. Now, type 2 is for parallel circuits. Now, how do we know if a circuit is parallel or not? We follow the current. And if it's parallel, you would have current dividers. Your resistors will divide the current. So let's take a look at a certain circuit. If we had to follow this current out of the circuit, it goes in the wire here until this point. And then it's got options to go to different resistors, meaning it needs to split up. That's how we know it's in parallel. Alright, so let's label these again. We have R1, R2, and R3. Alright, now formula is a little different for the squishing effect here. We still need to squish it, but to squish it, we need to follow the parallel formula, which is 1 over Rp equals 1 over all the resistors in parallel. So 1 over R1 plus 1 over R2 plus 1 over R3. Alright, and then you're going to get a certain answer there. Now your answer would generate a value of whatever that was. Alright, so 1 over Rp would equal something. Now to get Rp alone, let's say this is X, by the way. To get Rp alone, that would be 1 over Rp to the power of negative 1. So essentially, if we use this X here, then we would get X to the power of negative 1. Okay, this is a little tricky, so I'm going to do this with numbers to make it make sense, of course. But what this minus 1 here actually means is just flip the values. Alright. Anyways, so our switcheroo or our flipping effect here would actually get a value of Rp. And again, after you squish R1, R2, and R3, after you squish them all together in one resistor over here, you get Rp, your effective resistance. Okay, so let's take a look at what happens when we involve numbers. So we have our parallel circuit, and we're aware that we need to do a squishing effect. We need to take these three and squish them into one, right? So let's say they asked you in this circuit here on the left, let's say they said find the effective resistance if it is given that R1 is 3 ohms, R2 is 2 ohms, and R3 is 3 ohms. Alright, so again, we start with the formula 1 over Rp equals 1 over R1. Please remember to always write your formula. 1 over R2 plus 1 over R3. And substituting in, we get 1 over 3 plus 1 over 2 plus 1 over 3. Alright, applying the laws of fractions there, we know our LCD is 6. So that's going to become 2 over 6 plus 3 over 6 plus 2 over 6, which would give us 7 over 6. But again, what we just found was 1 over Rp equals 7 over 6. So we simply need to flip that over to get Rp. So Rp over 1 would equal 6 over 7 ohms. Meaning once we've done the squish, the whole resistance of this parallel circuit would be 6 over 7 ohms. Meaning if we had to look at the current flowing through here, like we would look at the current flowing through this, and if we had to imagine these three resistors are now one resistor, the current would flow through it like that. And the resistance to that current would be 6 over 7 ohms. We do need to remember, however, that type 1 and type 2 are generally easy, and they are very rarely asked in your papers, especially grade 10, 11, and 12. We now look at the following. Type 3, the combined circuit. And again, we need to follow the current to see which is in parallel and which not. So your combined circuits generally look like the one on the screen right now. And if you had to follow this current, you would start off, conventional current always goes from the positive end of the battery. We go down, it cuts straight through this resistor, it goes so much straight through it. So that means this resistor is in series. And so it carries on, and at this point it would split. Now wherever the current splits, those resistors are in parallel to each other. And then it comes back here to this point and carries on. Alright, so we don't necessarily want to look at P and S, but we needed to note which was in series and which was not. I would like to name these resistors R1, R2, and R3. Alright, now when you get a combined circuit, you first need to focus on the parallel current. Focus on parallel resistors. Okay, that is NB, very, very, very important. So if you squish them to form one resistance, what you essentially do is you create a series circuit for yourself. See there? So by squishing the parallel circuit, you get one resistor over there, which would be R parallel. This is still R1 over here, but that's R parallel. Now, something I want to point out. Now we have a series circuit. So now we can consider this to be our resistor in series. And what we then do after that is we use the formula R total equals whatever resistors were in series originally. So that was R1 now, but we're going to label that RS. And we add the parallel connection to that. And that's how we find our total effective resistance. So what that would look like is the diagram that just appeared on the screen now. So when you combine these two together, you get one resistance over there, and that we can label RT. Alright, let's take a look at numbers. So let's say they said find the effective resistance of, and they provided a combined circuit again. And this combined circuit had the values of 3 ohms, 2 ohms, and 3 ohms. Alright, so again, what did I say? Step 1, focus on the parallel resistors. So we have our formula 1 over Rp equals 1 over R2 plus 1 over R3. Okay, why did I say R2 and R3 and why not R1? R1 is in series over here if you followed that current. Okay, so that's equals to 1 over 2 plus 1 over 3. LCD being 6, so that would be 3 plus 2 over 6, and that would equal 5 over 6. Am I done? No, I am not. We need to get RP, so R parallel would be these two flipping around, which would become 6 over 5 ohms. Alright, so what we essentially have, if we have to look at the numbers, is we still have that 3 ohms, that we haven't touched, but this has now become 6 over 5 ohms. Alright, and now, as promised, we can find the effective resistance, R total, equals R series plus R parallel, which would give you 3 plus 6 over 5, and adding those together, you would get 21. Yes, 21 over 5. And simplified, 5 goes into 21, 4, and 1 over 5. So our final resistor would have the value of 4 and 1 over 5 ohms. Ladies and gentlemen, thank you so much for watching. Please like, subscribe, and share, and become part of the Whiteboard family.